Hello everyone, I'm Hassan Khan, and this is the another task of a machine learning algorithm. This is the unsupervised learning, and this is the GRIP 21 Data Science Business Analytics internship. In the first cell, we import the libraries. This is the NumPy for numbers, Pandas for data frame, Matplotlib and Seaborn is used for visualization. KME is the unsupervised machine learning algorithm library, and standardized and standard skill is the technique which we will discuss later. Uh, and train and test split. This is the this is our this in it means that uh, in two parts we split our data set in two parts: train and test. And this is label encoder library. We will discuss later also. In the second file, we load the dataset, array dataset in data column in data variable. Then explanatory data analysis technique start. In the first cell of the explanatory data analysis, data dot head first five first five rows of the dataset. Then we find the categorical variable of our dataset, and you see that ID is not categorical, cell length is not also categorical, and with petal length and petal width centimeter is also not categorical because false, 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 false. But species column is categorical. You also see the iris, setosa, etc. Then we use label encoder technique. Label encoder technique is used to category is used to give a number a category variable. It means that iris set as label encoder give a number iris set as 0 if one and so and another means it means that label encoder is used for label the classes. If we have three different classes, then label encoder uh, provides a number. First one is 0, first class is 0, and second class is 1, and the third class uh, assigned 2 number. Because why we use this technique? Because in machine learning algorithm we use numbers and we use we train numbers and because our machine learning algorithm um, our machine learning algorithm is used as better understanding of numbers as compared to categorical. Then data row shape, which means there 150 rows in our data set and 6 columns: 1, 2, 3, 4, 5, 6. And the data row describe. It means the uh, count of the ID, number of number of rows of ID, number of rows of supplement, number of and so on. Then mean value of ID, mean value of sepal length, mean value of sepal width centimeter, and mean value of petal length centimeter. And standard deviation is the raw of standard deviation, minimum value of each column, first percentile of each column, second percentile, third percentile, and this is the maximum value of each column. Data.info describe as data type if you show. First one is integer, second one is float, third float, fourth float, fifth float. But if you see that the last column is integer, and you in the above you see that their species is the object, means categorical variable, but after the performing label encoder, you see that species is integer. Then we find null values of our dataset, and you see that no null values in our dataset. Then we find a column. It means that a specific column of value counts. It means how many classes and how many uh, how many classes and how much each class. In zero class there are 50. One class also 50 rows. Two class also has 50 rows. Then we use count plot. uh, 0, 50. One first class is also 50. Second class is also 50. This is the correlation technique. ID sepal length. If we want to relationship between sepal length and sepal width, you see that minus 0.11. Minus means negative correlation and the positive means positive correlations. If you find if we want to find a petal length centimeter with uh, a petal width a centimeter, you also say that this 0.96 it's a very good correlation between these two. Then we split our data set. First five rows, first fourth from second drawn some from second column to second last column, and the last column classes. This is the scaling technique. Why we use scaling technique? Feature scaling is a technique to standardize the independent feature present in the data in fixed range. If feature scaling is not done, then machine learning algorithm tends to weight greater values higher and consider smaller values as the lower values. That's why we use scaling technique. Copy data, we transform copy data. Copy data is the second column from second column to uh, second last column. Then y is the output variable. In this we see that 0.3 test size. It means that we train our model 70% and test our model 30%. Then we create our model. In this we find cluster because in K-means algorithm uh, finding cluster is very important, and this is the technique to find the best cluster for our dataset. And you all see that uh, if you see that maximum iteration is 300 and initial is 10, start from 10, and if you see that uh, this is the number of cluster, and this sum of square error in only in one cluster. If you have one cluster, if you see that in the first cluster, if you have only one cluster, the sum of square error is so many so much as 400. But if we increase the cluster to the sum of square is, and the sum of square is between 100 and 200. Then if you have three cluster, the sum of square is decrease or decrease, and the sum of square is less than 100. But what value we choose for cluster? You see that this is the curve. This is also curve. If your if your elbow plot has an curve, it means that this type of curve. It means that your number of cluster for this data set is that one. I choose 3 because uh, our k-means algorithm tells that 3 is the best cluster for our data set. So I choose number 3. Number the you see number of cluster 3. K-mean plus plus, maximum iteration 300, initial 100, random state 0. It means that our model, why we random state well, what is the random state? It means that our model will consistently perform work well. Not for consistent, random state is used only for consistency. Then we fit our model, fit x train when x train value means that we see that see before we split our data set into two parts, train and test. So we fit the uh, train data in our model. Then we predict the train. Then we predict the test data set, and you see that 1 2 0 0 predict the classes. Uh, This is the scatter plot, and there's zero classes of this zero classes, this is the one classes, and this is the two second classes, and mm, and red is the centroid of the first class, centroid of the second class, centroid of the third class. So this is the k-mean task. Thank you everyone.